All right, so welcome back everyone. Today we're going to be looking at multiple inequalities at once. There's two cases. The first case we're going to be looking at is if you have an and. So they'll give you two inequalities and they'll say that both of these need to be true. So for example, this first problem we have 2x plus 1 is greater than 7 and 3x is less than or equal to 18. So we're trying to find the set of numbers that would make both of these true. And we'll kind of see why that is at the end. So we're just going to solve these like we normally would. So for this first one, we're going to subtract 1. We'd have 2x is greater than 6. And then we could divide that 2 over. So ultimately, this would simplify to x is greater than 3. For the other equation, or the other inequality, sorry, I'm going to do this one in red, but it would just be a simple one step, just divide by 3. And you would end up with x is less than or equal to 6. So when we graph these, if it's an and, you want to look for the overlap. That's kind of our key idea. So if I draw a number line, since I have 3 and 6, I know that's kind of the numbers I need to hit. So 1, 2, 3, 4, 5, 6. When you make your own number line, just make sure it includes both of the values in your inequalities. So for this first one, it's going to be an open circle, and it's going to go towards the right. If you have two different colors, it's helpful. If not, what we're going to do is I'm going to kind of draw my answers above. So for this first one in blue, I would have an open circle at 3, and it would go towards the right. For the second one I'm going to do in red, and I'll draw it below the number line, it's going to be a closed circle, and it's going to go towards the left. So I'd put a closed circle, and it would shade this way. So you kind of want to look at your number line and kind of look at where these overlap. I don't know how easy it's to see. Hopefully you can see this in the video, but the overlap would be between, well, it wouldn't include 3 because we have an open circle, but between 3 and 6, include in 6 would be our answer because it's a closed circle. So this would be our answer. Where do they overlap? And it makes sense because, for example, like pick any number in between this range. Like, for example, 4. 4 is greater than 3, and 4 is less than or equal to 6 as well. That's true. If you picked 5, well, 5 is greater than 3. And 5 is also less than or equal to 6. It makes both of those inequalities true. So if you see an and between two inequalities, you're going to be looking for the overlap. The other situation you can have is if it's an or inequality. So for this problem, we have 7 plus x is greater than or equal to 6, or 8 plus k is less than 3. So the first thing you want to do is just solve these. So this first one, you would just subtract 7. So you would end up with x is greater than or equal to -1. The second one, we're just going to subtract the 8 over. So you would have k is less than -5. Oops, I was supposed to make these both x's. So let's just change that to an x. I'm sorry. I was copying these from the book and they use K's, but I switched them into X's, so that's why there's 2 letters. But let's not focus too much on that. We've got our 2 inequalities. So we just want to make either one of these true. So we're just going to draw our number line. And like I said, when you make your number line, make sure it includes these values of your inequality. So I need to have a -1 and I need to have a -5. So I need more negatives than the last one. So I'm just going to go down from 0 until I get to -5. You could go further if you want, but you need to at least get to -5. And then we're going to just graph these. And we're going to see, for this first one I'm going to do in blue, well, it's going to be a closed, and it's going to go towards the right. So at -1, shade towards the right. For the red function, we're going to have an open circle, and we're going to go towards the left. So open, sorry, that's an open circle, and we're going to go towards the left. And notice it doesn't overlap, but that's okay. Both pieces of these are part of our solution. They just go in opposite directions. They don't have to either. They could overlap, but with an or inequality, you're just going to graph both and see what it covers on your line. It's only when you have an and inequality you're interested in the overlap, if that makes sense.